So I guess we can get started. So welcome everyone to this webinar on forecasting and decision making. We are very happy to talk about this topic because it's a topic we are working quite a lot at PyMC Labs. It's probably a different type of kind of the classical forecasting kind of content that we usually see, which is great, by the way, but we want to give it a bit of a different angle. And this is what we want to share with you today. And it would be great if you could give us feedback about the topic, if that resonates to kind of your experience, what you're looking for or not. And it would be great to have such a feedback. So once again, we're here about forecasting for decision making. At webinar by PyMC Labs. So who we are? Well, I'm Juan Orduz. I'm a principal data scientist at PyMC Labs. I've been working for labs for almost 2 years, and now I'm mainly working around open source packages like PyMC Marketing and Partial Py. I'm kind of working with clients to actually put this into practice, not just by the model development, but also thinking about strategy and also deployment. So very much kind of hands-on and to real products. And one component of these products that we work is actually forecasting in the context of decision making. So I'm gonna introduce, or let's say, let my peers introduce themselves. So Teemu.
Yeah, hello everyone, and also from my behalf, very happy to be talking today. So I'm Teemu Säilynoja. I work as a principal data scientist here at PyMC Labs. My background is in Bayesian modeling, and lately I've been mostly focusing on marketing analytics, where we will see today that there's plenty of examples of forecasting for decision making that lends itself very well for marketing decisions.
All right, maybe now we can continue with Camilo.
Sure. Hello, everybody. It's a pleasure to be here. My name is Camilo Saldarriaga. I have been doing 2 years with PyMC Labs now. My background is in finance. I'm a PhD candidate in finance in the doctoral school at Sorbonne, and I work mainly using Bayesian stats for financial forecast and portfolio optimization using the Bayesian approach.
All right, cool. So thank you to my great team that we have today. We have prepared very interesting material. So before we start, this is not a sales call. Like, we don't want to try to pitch you anything in particular. I guess our objective is to kind of have a discussion about a different angle where we could see forecasting problems, in particular for industrial applications. So just to frame what we want to work today. Maybe we start with the why. Why are we interested in forecasting for decision making, and why is it relevant for us at PyMC Labs and potentially for you? Well, at least I've seen, or let's say in my experience in this topic, is that approximately 80% of the time someone asks me for a forecasting model, say in marketing or in supply chain or a similar field, they don't actually need a forecasting model, but more a decision engine, right? So in the context of marketing analytics, okay, what would be, let's say, the future number of customers acquired if I spend X amount of money in marketing? In many cases, they're not interested in the forecast itself, but more on the question about marketing efficiency and what can I do, or what will happen if I reduce my budget or actually increase my budget or actually change the budget mix. In addition, when we think about supply chain, in many cases, what you want to understand is the kind of demand and also how to capture it through, for example, pricing. So like a forecast by itself is definitely useful, but ultimately you would also want to tie this to the question about difference in pricing policies, or how should I drive discounts to actually do some markdown optimizations to get my inventory being cleared out. So this is one of the motivations that kind of the forecast itself can be useful, but in many cases, it's not the end goal of the analytical question. So yeah, this is what we want to do today. And of course, Camilo was going to talk about kind of how we can use this forecast to do some optimization, for example, in the sense of minimizing risk. That could be also in supply chain or the financial sector. Yeah, so this is kind of the business problems that we typically see. So one is I need a forecast. And in this case, your task is, as a data scientist, data analyst, really create forecasting models to be able to have a good prediction of the future, given the historical data. And there are great packages and kind of frameworks to do this. So among ones is Nixla, with all of the packages like stat forecast, ML forecast, neural forecast. I think kind of this is basically a very rich ecosystem where for this type of problem, this works quite well. We also have now the machine learning kind of approach where we can tie a forecasting model as a kind of combination between a time series model and a machine learning model. So throwing like a light GBM or AutoML can work pretty well. And also the pre-trained models, like the foundation models, actually work pretty well. You can fine-tune these models at regressors. So it's a very interesting evolving field. And I guess we kind of can tackle those problems, but actually we want to focus on the other type of questions, which is about, okay, I get a forecast, how I can act on it, reason about interventions to actually maximize or minimize something. So think about supply chain, about price, about marketing analytics, about kind of spend in marketing and in finance, about risk in minimization in the context of portfolio management. Yeah, so this is kind of what we want to tackle. And even if you use all of these kind of machinery to just get a forecast, let's say stats models or exponential smoothing, there's another layer which can be there kind of downstream, which is the decision layer, right? So even if you have like a forecast with kind of credible intervals, at the very end, you want to do certain type of optimization. And we will see later today that we can think about many kind of policies to do this optimization by taking the output of the forecast and the uncertainty in an optimal way. Thinking about supply chain, okay, you do the forecast, but how are you going to do the inventory management, knowing that if you order milk, that's going to take 3 days to arrive, and then you need to do all of this analysis to really make sure that you do something actionable, and the point forecast model, like the raw forecast, is not going to cut it. So the core capabilities we're interested in is something around the context of causal forecasting, which means that we want to understand the kind of forecast as an output of an input that we can intervene on and run kind of what if simulations. So again, price elasticity, price fluctuation, or marketing kind of optimization in the context of marketing analytics. There's another, let's say the second layer, which is the decision theoretic optimization, which means, okay, I have the forecast from a model. What do I do with that, right? At the very end of the day, I want to do certain type of optimization, which I can achieve through the input of the model from point one. Again, another thing that we have explored quite a lot is that the point forecast can be kind of very informative signal, but actually the whole posterior distribution, the uncertainty, can serve as an additional and very valuable kind of data points for decision making. For example, in the context of marketing analytics, depending on kind of how risk how much risk do you want to take, we can not only optimize on the budget mix, but also on the risk that you're willing to take, with, of course, potential higher gains if we take a higher risk. And in many cases, when we think about forecasting and maybe think about an AutoML or light GBM, we're kind of forgetting about the mechanism on how this is generated. And in the context of marketing, for instance, we kind of know a bit about how marketing spend maps to conversion on sales. We know that saturation effects are important, ad hoc effects are important. We also have kind of in econometrics laws about or ideas about how price could affect sales. So we want to make sure that we take all of this information from these mechanisms and make something meaningful from it. And also in the financial sector, there's a lot of theory about kind of how prices or kind of different inputs for portfolio management work together. And and again, the decisions is something that should happen in a continuous basis, which means like having a one-time forecast and one-time optimization can be useful, but we're also thinking about how this can be seen as a data product, meaning how these forecasting and decision layers can actually deploy in modern kind of ML infrastructure, because we want to make sure that we can scale efficiently. And last but not least, something that we're exploring at Labs, and I think it's a very interesting topic, is like how do we integrate the agentic layer? And kind of with the kind of initiatives on decision AI, we have seen that for both the forecasting kind of model development for the decision layer, kind of the agentic side can be very, very useful. So this is something that we are very interested in Lab and would love to hear your thoughts about, let's say, if this resonates with you. So at the moment, because kind of we really like and have experience with Bayesian models, we really take care of the whole ecosystem, or at least the big Python ecosystem. So on the one hand side, we work with PyMC. We can also work with Jackson and Paro depending on the application. So again, we care about the solution and less about the tools, because at the very end of the day, we want to build, let's say, solve a concrete problem. And so for that, we're actually trying to make these kind of forecasting methods more accessible for all practitioners. And that's why recently we have open source 2 packages. One is NumPy-Forecast and PyMC-Forecast, which are essentially the same API for these 2 probabilistic programming languages. And the idea is that these packages take a lot of the boilerplate that you will need to do yourself when working with these models. That doesn't mean that we're going to re-implement ARIMA, exponential smoothing, or any kind of light GBM model, because kind of that's a different layer. What we want to do is have a setting where you implement your own model. So this is like just implement the forward path, the forecasting model, and then these packages can help you to do a time-slice cross-validation, metric evaluation, and also give you the infrastructure to scale this. We will see that later today. So please take a look. This was basically inspired on the Pyro-Forecast module, which means that we're building on top of giants, so to say. So please take a look at these packages. We have a lot of examples, and provide us feedback, because we would like to keep maintaining and providing more functionalities on this project. And again, we are not seeing kind of forecasting as just one area of expertise, or like one kind of siloed vertical, but we want to actually see it as a like kind of horizontal across many type of projects. And the kind of consequence of that is that we are seeing that the Bayesian forecasting tools in the Python ecosystem are actually expanding and coming together quite nicely. So very recently, we released PyMC Marketing version 1.0, and in that release, we actually showcase how you can combine classical, let's say, media mix models, which by themselves can be seen as forecasting models, with vector autoregressive models, VAR models, to estimate kind of long-term brand efficiency. And this has been an idea that I think has been there since 4 or 5 years, let's say 4 or 3 years, by a paper by Kane. And we're making this kind of easy to implement because of kind of various reasons. One, PyMC marketing is becoming more flexible as a way of building models, but also there's a new, very nice package called Impulso, which brings VAR models built on top of PyMC in PyMC with a very friendly API, which can be combined, which means, again, Impulso can be used in a generic PyMC model and in particular in PyMC marketing. So please check this example out because this is exactly the type of work that we're interested in. And another thing that I want to mention also to maybe kind of fight against some kind of all kind of prejudice is the fact that these forecasting models don't scale, or that in general they're very slow. And I've seen and I've kind of implemented models, let's say forecasting models at scale, on which one we get the benefit of having, let's say, a clear mechanism to understand price elasticity, out of stock signals in a very kind of principled way, while deploying this and running these models at scale. Typically at that scale, running MCMC can be very expensive, but variational approximations have proven, let's say, in practice to work very, very well. So just to make this quite tangible in both PyMC-Forecast and non-PyMC-Forecast, we have this example data set of a kind of retailer where we want to kind of forecast the demand in the future given the previous sales. And we have a very interesting predictor, which is like kind of the availability. Say, was this product available during this period? And that's basically a number between 0 and 1. And of course, let's say that if you have 0 sales, it's different is if the 0 sales is because you didn't sell anything, meaning people didn't care about it, or because you didn't have stock at that day. So being able to model this efficiently is very important in many applications. So kind of this plot shows kind of the gist of what we do. So we have like a very kind of a nice mechanistic causal model to model sales as a function of various inputs and also this availability constraint. And kind of we see the in-sample fit. So this is kind of the orange line. So this is the credible intervals. The observed data is the black one. So this is our prediction. And the red line kind of just represents the availability as a number between 0 and 10. So in this drop, we see that the availability dropped to around 0.4, and therefore sales also dropped, which kind of makes sense. But at the very end, we actually don't care about this. We actually care about what would have been the sales, or let's say what would be the estimated latent demand if we had had an availability of 0, right? Because that's kind of our potential. And here the predictions look, of course, shifted upwards because the availability is here is around 0.90 something. But we can see a big difference here where, of course, at the end of the day, I don't care about this prediction, but about the, let's say, forecast of the latent demand, which is the green line. And this is actually what we use in practice to do optimization. We didn't, or of course, you don't know the availability in the future. And the what if scenario, okay, what if availability is equal to 1? That's one way, but you could also take the general predictions for availability values, which are, for example, the historical average or the worst case scenario. So this is a hierarchical model with very custom components, and we were able to fit this on 50,000 time series with a GPU on a platform called Model, but you could do this in AWS or Google Cloud in less than 10 minutes. And non-PyMC-Forecast and PyMC-Forecast kind of make this kind of easy for you to do, just because kind of the inference is kind of separated from the posterior sampling, and we have done a lot of optimization to make this more accessible. So kind of this is possible. The code is live, so please try it out. Yeah, kind of, and I've scaled these models to much bigger data sets. So kind of this was just a bit to motivate what we're interested in, and now we are going to share with you some concrete industry examples which go in the direction along these lines, but maybe touch on some specific pieces. So yeah, I'm gonna give the stage to Teemu to talk about causal interventions and price elasticity.
Thank you, Juan. Yeah, so kind of returning backwards to examples that Juan has already crossed over, but let's go a bit deeper. So the first building blocks is that when we are able to build a forecasting model that actually takes the controllable levers as the inputs. So how do we make forecasts where we can actually also intervene with our decisions and then forecast with what if situations. And here we have the do operator, which allows us to take a PyMC model, which under the hood has a graph representing the model, and we can replace the data that has been, for example, used in the training with, and here you can see the data. Thank you for the highlights. So we take as input the price. We are now building a log price or demand model actually, which takes as an input the price, and then we are trying to predict demand from those prices. And after we have fitted the model and we have gained some information on the price elasticity, then we can start running scenarios of what would happen to our demand if we take certain actions. And this of course expands to many other examples. Very common example in marketing mix models would be marketing spend, where our scenarios, where our scenarios would then be marketing budgets, how to allocate it between channels, but also what is the timing of these different campaigns. Yes, thank you. Next, yeah, and another key modeling type that we have found interesting that also comes up very often are these cases of censored demand. So somehow how we are gaining observations does not necessarily actually allow us to directly observe what we are interested in this case demand. There might be a stockout or some other feature in the real world that actually does not allow us to observe demand if it goes too high, like Juan explained earlier with the example. So this is exactly the case that then if you have a stockout, your demand or sales can go higher than a certain level, then you will be underestimating your demand or potentially underestimating how effective a certain campaign is for increasing the demand, as the demand is actually limited by something else. And when you explicitly include this into your models, then you can start running cases where, well, what if we increase our cap? We have more shelf space and we can actually allow the demand to be increased. Would we then observe or not? We have more capacity. Will the demand also then increase when the capacity is there? We have good links there on the slide. Can you go to the previous one?
Yeah.
So yeah, two examples on the slides. First one is Juan's own blog post in our labs blogs about different opportunities for time series analysis. And the next one is this funnel-aware MMM, where we actually have the censored demand happening inside the marketing funnel. Thank you. Next. And now this is the kind of third kind of prediction or modeling kind of utility that we can drive with these decision-focused forecasting models. So this would apply even for forecasting models where you can't actually affect the forecasts with your decisions, but you will do actions based on the decisions. This can also be models that actually also you will affect the forecasted events. But instead of directly optimizing, for example, just sales, you can, of course, have some kind of utility or loss function that you are trying to optimize against. Penalizing risks is a common type. So, for example, in MMMs, in PyMC marketing, we have examples of how to do marketing campaign planning with also taking into account the uncertainty of the model in these campaign decisions. And as you can see on the links on the bottom of the slide, this will be that we also have a full webinar on the topic recorded on and in a blog post on energy forecasting. So this is a common field of application for this. You forecast energy production, especially with renewables. These are not necessarily so easy to predict, so there's a lot of uncertainty in the predictions, and then there are some asymmetric penalties if you don't produce enough, and of course you're trying to anyway sell the produced electricity forward. So interesting, sometimes very complex models that benefit from decisions. And now I'm going to hand to Camilo as the expert on.
Sure, Teemu, thank you. Well, first of all, financial institutions face a lot of different problems. Some of them, as Bo mentioned in the questions, can be more related to predicting the different payments. For example, in this case, he mentioned like some car loan payments. It's absolutely possible to build good time series models of this and model also potential interventions and their outcomes. This is something perfectly doable in the framework that we just shared, and it's actually one of the biggest strengths of the approach of the Pearls Do operator. But also we have some other showcases, for example, in the case of portfolio management, where this is extremely powerful, and we handle this approach in 2 steps. The first one, which is not very different as the ones Juan presented, is basically, well, we need to forecast the expected returns. Like, what do we think is going to happen with future returns? And in this sense, the PyMC ecosystems offers extremely powerful Bayesian models to provide this. But in the second step, and here's I think where we can provide a huge amount of value, is that we don't obtain only point predictions for those future returns. We obtain full distributions of those predictions. And in the traditional portfolio theory, well, basically we use just like the expected returns value, the point estimates, and the covariance matrix structure. And with that, we build a whole portfolio. Here we have a whole new universe of information that we can use to optimize the portfolio. And this is a perfect fit, especially for risk management, because it allows us to have a full probability distribution of the future returns on each possible portfolio that we can build. And with that, we can optimize based also on the risk that the customer wants to have, the risk he wants to buy. And this is a very, very good fit for a value at risk approach, for conditionally value at risk approach, and allows us to handle the problem, which are bigger set of information, and to obtain definitely more interesting results. And we will mention like another finance very nice use case in a couple of slides. So we can continue.
All right. So now we want to present the case study like that we published a couple of weeks ago, and it's about prices, like oil prices, because they're off to the roof, and we'll be interested in seeing if there's a interesting way to do such prediction in these volatile times. So I think I'm going to give the stage to Teemu.
Yes. Yeah. So just to preface the problem, as one said, very volatile and also very high oil prices at the moment, and this can mean that you have key decisions that you want to make, and you want to time them at the best possible time with the knowledge you currently have, and we recently published a blog post on the topic to also show how agentic workflows can help in approaching problems like this, where the modeling question can be, in a way, quite open when you start approaching it. And then the next slide. Thank you. So for this, we use Decision Lab, which is, in short, a harness for agentic data science. So in addition to coding, when you're doing data science, you also want to pay a lot of attention to the modeling decisions, and that your analysis is actually sound. So it's not enough that the code runs without errors. And Decision Lab encapsulates approaches towards this. The key idea is to run this analysis problem multiple ways. So kind of exploring this forking path or garden of possible decisions during the modeling process. Which kind of model are you using? Perhaps there are some key possible options for the causal structure that you're modeling. And for this, to this end, you can determine your modeling question, and you have an orchestrator agent that runs this with different options. And if you see that, okay, most of these different modeling decisions, they start ending up into the same decisions or same conclusions, then this is a very powerful way to quickly explore a large variety of modeling decisions, and you can see that, okay, I should trust my results. It doesn't look like there are many modeling decisions that will actually, within reason, change the results. Or you can see that, okay, now the results are actually depending a lot on some decisions made during the modeling process. And this is then where you can jump in to use your own judgment. These are places where you need to then pay a lot of attention. And then you have a way to approach into finding these stages fast. And the key idea is also that you package these approaches. So you can make decision packs that contain the prompt for your specific forecasting problem or analysis problem, some relevant skills, and you package this into a reproducible environment, lock your dependencies, and you can run your analysis again and again. If you get new data, you're facing the same question again later on. And for this, we then built a decision lab for the decision pack for the question and problem just described for oil prices. And I will hand for Camilo.
Thanks, Teemu. I really like this example. I'm a huge fan of Decision Lab because, well, we all know how powerful AI is. We have experienced the really quick progress it has been making, but it's not yet fully capable of delivering strong analytical data science, analytical processes. But what we build here is basically a whole infrastructure, a harness that allows you to be confident in the capacity of having a set of agents solving these kind of problems for you. And we build this. It actually has now 2 packs. We basically create a subset of capacities of this decision lab to analyze specific problems. This is an open source approach. And we tested one of these packs by posting one of the most relevant questions of the last months that we all have been suffering directly or indirectly, which is, well, knowing the historical trends and the historical behavior of oil prices, we ask these agents to build an analysis of what's going to happen and a set of predictions, a Bayesian model of what's going to happen during the next months with oil prices and when we'll come back to normality. And basically each decision pack, which are these submodels of the decision lab, contains a whole set of configurations, and in this case a number of options of possible models that it can check to answer the type of question. And we put this into the decision pack. And basically, well, we ask, knowing the current situation of oil prices, we set a threshold which corresponds to the 75th percentile of the oil price in 2025. And we ask it to build different approaches to know what are the probabilities of things going back to normal in the next months. So basically, you provide one command, one prompt, and a set of agents, in this case, 5 parallel agents, will analyze the problem, will provide different approaches, and will come up with one single decision. So maybe we can continue with the next one. And in this case, well, we provide this, the 5 different agents analyze the universe of models that they could use to address this kind of problem. And they concluded that the best option was to use what we call in finance a traditional jump diffusion model, which is a very well-known tool that allows us to model basically data sets, data patterns that have like noisy oscillations, but also very strong jumps, which is actually something very characteristic of oil. And also the model, the different agents agreed in this basic structure, but they also added OU component, which is the Ornstein-Uhlenbeck, basically that provides you an auto kind of a pool that goes, a mean reverting trend to the model. So this is the basic modeling structure that they agreed on. And this is actually quite of a good fit, because if you see the oil data that we have, in 1.5 of the days, 1.5% of the days, we have oscillation that more than 3 standard deviations, which is quite actually quite strong. Next one, and next one. And well, they all run the 5 agents, the analysis in parallel, and they come up with the conclusions. And then we have an orchestrator that basically joins all the different results and provide you with the answer to the question. And in this case, the system provides us the answer that the probability of the fork of the oil price going back to the 70th percentile, $68 per barrel, in the next month was 5.7 for the next month. This was done at the end of June. So we are quite actually doing well in the forecast right now. The probability was 27% for the process being reverted in the next 3 months, 48% in the next 6 months, and 68% in the next 12 months, with a median time to normalization of 88 days, which means like the median estimation according to the model will be around September 2026, and a probability of the problem of the price not being normalized in the next 12 months of 31%. And this is extremely useful, not just like for the sake of curiosity, but also to take purchasing decisions. Like a lot of companies have different inputs which are directly linked with oil prices, and this allows them to actually planify or have like a set of criteria for their procurement processes. Can continue to the next one. And here we have kind of a summary of the different results that the 5 agents obtained using the packages, and that the orchestrator managed to summarize to provide a unified answer. And we think this is kind of a cool example, and that Decision Lab is actually a very powerful tool that will continue to grow and to improve very rapidly in the next months. The next one. And as I mentioned, well, this can provide you very useful insights for procurement processes. Do you need to buy within the next 3 months? Well, according to our predictions, by now is not a bad idea, because there's 17% chance that the price will still be above 60.80 for September. If you need to buy during the next 6 to 12 months, you need to procure inputs for the next 6 to 12 months. Well, maybe it's better to stage those buys, because in the horizon of 6 months, the probability of the price being normalized is almost a coin flip with 44%. And well, I think this is quite nice and quite flexible, because it can be adapted to different kind of situations. Next one.
All right. So thank you, Camilo. I think this was a very, very nice example. And maybe just to bring everything together, in the first part of the presentation, we mainly talk how we are interested in this kind of structural forecasting model, where we add kind of domain knowledge, kind of domain structure, and a kind of also kind of causal point of view. And we have seen that each of these models can actually perform quite well. And kind of in the second part, we have seen that within the same mentality, we can scale this analysis by using harnesses like Decision Lab, which allow us to scale and kind of challenge and test this kind of model stacking a la agentic way. So again, it's part of the same concept. It's just that the agentic layer help us to scale, and we have seen a lot of very good results. So again, who is this for? Where basically I would claim that anyone using data for decision making, because at the very end, even if you don't want to understand kind of out of sample or like forecast per se, but kind of like more like past looking analysis, you can use these models to do that. This is very common in the context of marketing analytics, and also to reason about interventions. Questions like, what would have happened if I had increased my media spend by 30% in the last year? Of course, we can use that for kind of forward-looking estimations. So this is kind of a clear component. We have a lot of experts like Camilo working on the financial sector, where again, you have very kind of well-studied models. And we see that many of them, despite being kind of very kind of foundationally very correct and structured, might miss the fact that not all of them kind of have been explored in the Bayesian setting. Of course, they are, but not at mainstream. And I think there's a lot of potential to explore this field from the Bayesian and kind of structural point of view. And yeah, and also kind of if you're making decisions and deploying these, having a well-defined harness to do this is key. And we don't believe that just asking Claude, hey, fit this Bayesian model and hoping for the best is the best and more accurate way to make decisions in real business context. And we're working quite a lot and keep experimenting on how to better kind of understand and develop these agentic harnesses to make sure that the gains that we have gotten from this structural and kind of mechanistic driven forecasting model can scale in this era of AI. So that's pretty much it. This is what we wanted to present to you all. Again, it's about bringing these ideas to the community and seeing what resonates with you all. And I guess we have some time for questions. So maybe Teemu or Camilo, if there's any pressing question from the audience or the participants, I guess this could be an interesting point to open the stage.
Maybe, well, I answered on the chat, but I can just go through it very quickly. Bo asked if this kind of approach can be used to understand, for example, the charge-offs of financial institutions in the case of loans, when people will stop paying their loans, and also if we can do a simulation of interventions. And the answer is absolutely. This is actually a perfect fit for that, because we can build models of the behaviors of the payments using the historical data, and we can first understand the whole risk structure of this, and we can do simulations of interventions. If you take this measure, how can this impact the future payments? If you take this other one, what will be the impact? But also understand the full probability distribution of those results, so we can assess the risks and the upside gains of each possible intervention. And this is actually very linked to what we do in MMMs, which is mixed marketing models, where we actually model interventions in terms of spending in campaigns. Well, conceptually is not very different to what we can do for example, loan payments.
Yeah, there was another excellent, well, Juan first if it's for this, but I have another excellent question that came in the chat. So yeah, there was another question about in these censored demand models, if you also don't know the stock level, the availability, you can also include that into the model as an unknown. If you don't know if it was definitely a stockout that happened, you're predicting demand or estimating demand and also the stockout levels at the same time, and that is definitely possible. And I wanted to ask Juan, but I think it was actually the case in the example that you were showing.
Yes. So
yeah.
Let's say I had in a real application, I had the happy path where we were working with the analytics engineers to make sure that the data was well processed, because of course that's the key. And in that case, when there was a availability equal to 0, the sales were actually 0, which was great, because then, as you will see in the example, we were just adding kind of a global multiplicative factor, and if the ability goes to 0, then this was pushing the predictions to 0. In this case, however, there were a lot of points, around maybe kind of 15% of the cases, on which the availability was 0 in the data, but there were still sales on that day. And that typically happens on kind of when do you report availability, because maybe you report that at the end of the day, but then some of these products get shifted to the next day, and kind of there's a bit of a lag. And I mean, having the luxury of being able to control this data as well with your team, it's great, but in many cases, you don't have control for that. And in the example, we model kind of this latent gap, which also trying to quantify, let's say we didn't know exactly what was happening, but we were able to quantify this with a latent variable and actually estimate this quite well. And we could, of course, just estimate this 15%, but we could actually add regressors to see if there are previous signals that can hint on the precision of this buffer, so to say. So definitely check this example out, because there's a lot of discussion about how to do this, and we solve this kind of from the conceptual point of view, not just throwing more algorithms, but really reasoning about the mechanism. Yeah, that was very fun to work on. Do we have any other questions in the chat? If that's not the case, then I'll stop sharing. I mean, you can always reach to us at info@pymclabs.com or via LinkedIn. It was very nice to see you all. I hope you enjoyed this webinar as much as we did. We actually kind of really enjoyed preparing this. I guess there was a lot of material that was left out. But if you're interested, we can expand in these topics. And again, everything that we mentioned today, it's open source. So there's really no excuse for not trying this out. And so please give us your feedback, and yeah, kind of wish you a very pleasant afternoon. Thanks to my colleagues, Teemu and Camilo. Then see you next time.
Thank you, everyone.
Bye.
Bye. Have a nice day.